So when we are solving equations, okay, when we are solving, we are adding and subtracting rational expressions together, and now we are equal to another rational expression, right? We're still adding and subtracting, so what do you think we still need to have happen? We still need a common denominator, okay? That is still there. So here I have 9, 6, and 2. I cannot add those fractions together until they're all the same number. So what do we want to make them all to have? They can all become an 18? Minus. Right? Does that make sense? And I'm also going to go ahead and pop up those negatives so I can make this a plus problem. Okay. So if I can make the denominators 18, what did I do to 9 to make it into an 18? Multiplied it by 2. So that means I got to multiply this top guy by 2. This is now 2x squared, right? What did I do in the middle to that 6? Multiplied it by 3. So I got to do the top also. So that becomes 3x. My last piece, the 2 got multiplied by a 9. Got to do it to the top. So that will turn into a 9. So now we have 2x squared, plus negative 3x plus negative 9. Can I combine any like terms? No, I can't. Okay, but we are solving for x, so we're not done. Before adding and subtracting, we were done, right? We're actually equal to 0 now. So I can solve for my x value. I do that by just looking at my numerator. So once your denominator is the same, you don't need it anymore, okay? To solve the problem, you only need the pieces with the x, okay? It is going to be our numerator for this problem. Once your denominator is the same, you do not need it anymore. The end. It's done its job. It can go home, okay? Going back to first semester, I believe. We're going to slip and slide. Yay! All the things coming together. So let's slip the 2 to the end to give me what? Negative 18. What multiplies to give me negative 18 but adds to give me a negative 3? Sweet. And then we have to slide or divide our 2 back out. This becomes x minus 3, and this stays 3 halves. I cannot simplify that fraction anymore. We're solving for x, so make each piece equal to 0 and get our pieces out. Here we're going to get x is equal to positive 3. Over here we're going to get x is equal to negative 3 halves. Okay. Now before I circle anything, what did we always have to lift? What x could not equal, right? Domain restrictions. Is there any domain restrictions for this particular problem? No, because they're just numbers. There's no x's down there, so we're good. X can be anything. So here are my answers. So today is when those domain restrictions are going to matter. Because if we solve for x and one of those is an x that I can't have, then it's not an answer. It's an extraneous solution. Okay? Ready for the top middle? How about, no, I won't make you do it yet. All right, now we have x plus 1 over 3 plus x plus 1 over 6 equals 2x plus 1 over 2. What can we make the denominators all be? They can all be 6, right? So am I going to touch this guy? No, he's already perfect. Leave him alone, okay? But my other 2 pieces, what am I going to have to do to the first one? Multiply by 2, and then my last one, multiply by 3. So this first numerator is now 2x plus 2. We did not change this guy. He's fine. My x plus 1 is still there. But now we are equal to 6x plus 3. Okay. Do I even need to write the denominator? No, you don't even have to write it, okay? You've done the work you need to do to make them the same, which has altered our numerators. You don't need it anymore. Save some space. Okay. Now we're going to combine like terms. Look over here. 2x plus x, 2 plus 1. I'm going to subtract this guy over here, subtract 3x. Boop. Lots of 3's. Subtract this 3 over here. I get 0 equals 3x. Divide by 3, what do we get? 0. Am I allowed to have x equal 0? Yes, I am. Okay. We should have to be able to plug it in and it work. So why is this one not working? So you should be able to plug it back in and it should become a true statement. So when we plug these in and we use our whole fraction from the original, here 0 plus 1, that's 1/3. Here 0 plus 1, that gives me 1/6. This equals 1/2. Okay, and that is a true statement. This is the same thing as what? 2/6, which gives me 3/6, which is 1/2. So you should always be able to plug your answer back in and make sure that it does work and become a true statement. Okay, so we're trying to find the x value that makes it true. Would you like to try the next one? Yeah? Okay. Y'all try this one. 2x times 3x plus 1 over 5 minus x plus 1 over 2 equals 1 over 10. Okay? You try this one. All right, so a lot happened with this one. Okay? So our common denominator, we can all make them a 10, right? So my equals 1 at the end is going to stay equals 1 because they already had the 10. My first numerator needs to get multiplied by 2. Now the numerator that was already there, 2x times 3x plus 1, I multiplied those together to get 6x squared plus 2x, and then multiplied that by the 2 that it needed. Okay, so that is the original. I didn't change anything right here. I just multiplied those together to get this. And then I multiplied by the 2 I brought in. Okay, the next one, it needs a 5. So I have to multiply my numerator by 5. So when I multiply x plus 1 by 5, I get 5x plus 5. But we are subtracting. So I got to make sure I distribute that negative to both pieces. That's where I get negative 5x minus 5 from. Okay. We are solving, so we got to make it equal to 0. Bring everything to one side. This becomes a slip and slide problem. You should end up with x equals 3/4 and negative 2/3. Questions? Yes.
I multiplied the 2x over, or 2x times 3x plus 1. I multiplied the 2 to every side.
You should still get the same thing.
But I multiplied the 2 and I got 6x times 4.
6x squared. Because x times x. Yeah, that x has to be a squared.
No, I'm saying when I multiplied, so you know you have that 2 on the outside of
Uh-huh.
it? I multiplied that 2 to the 2x.
Uh-huh.
I got 4x. And I multiplied that 2 to the 3x and got 6x. So
And the 1.
So I got 4x times 6x.
You guys went 4x squared.
Yeah.
I did, that's what I got. I did exactly the same first.
You need, yeah, because of PEMDAS, you have to distribute first. You're multiplying it more. You're doing it 1 more than you need to if you do it that way. Yeah, do your parentheses first and then multiply. Any other questions? Because now we're going to start putting x's in the bottom. So none of these had a domain restriction to worry about because it was just numbers, right? All right, so coming down here. So to solve radical equations, We need to get rid of all the fractions. So what are we doing to make that happen? Yes. So we have to find the common denominator. Okay. And I talked about it. What is now going to make a solution considered to be an extraneous solution? If the solution we find is what? If it's a domain restriction. If the solution we get is a domain restriction. Okay, so we're finding the common denominator just like before. Now we got to make sure my x's are not part of my domain restriction. If we do, that's considered an extraneous solution. All right, here's our first one. 10 over x squared minus 4 equals 1 minus 1 over x plus 2. Okay, what is our first denominator? X squared minus 4. Can you factor that? Yes, it is going to be x plus 2 and x minus 2. Good. Is anyone still writing down the stuff in the middle? Okay. What is my denominator for the number 1? 1. And what's my denominator for the last part? X plus 2. Are we cool if I go ahead and pop this negative up? Is that okay? Okay. All right. So what is going to be our common denominator?
X plus 2, x minus 2.
X plus 2 and x minus 2. Does my first fraction, is it missing any of those pieces? No. So 10 is good. 10 equals. Is my next piece missing any of those denominators? He's missing both of them, right? So we got to bring in the x plus 2 and x minus 2.
Wait, that just
Okay.
2x.
It will. Well, not 2x. It's going to be the x squared minus 4.
Okay.
And then plus, we have this negative 1 right here. Is it missing anything? What is it missing? The x minus 2. Does it make sense what I'm trying to show here? So my black numbers were my numerators. The purple that I used is the missing denominators that we have to bring in. Okay. I'm not writing it like this because 1, it's going to get messy. 2, once we make them the same, we don't need our denominators, right? So all we have to focus on is multiplying our numerators by what's the missing piece. Okay. So this is 10. This piece is the x squared minus 4. Good. And this becomes what? Negative x plus 2. We need to combine like terms and get everything moved over to one side. So I'm going to have x squared. I'm going to have minus x in the middle. What's going to be on the end? Okay, so negative 4 plus 2, combine those, and then I have to subtract 10 over, so this should have a negative 12 on the end. Did I lose anybody? I did like 2 steps to 1 right there. I combined like terms. Negative 4 plus 2 is negative 2, and I subtracted 10. All right, so multiplies to give me negative 12, adds to give me negative 1. Negative 4, positive 3. So x equals what? Positive 4 and negative 3. I'm not going to circle them. We need to make sure that I can actually use these answers. What is my domain restriction? X cannot equal 2 or negative 2. So am I okay? Yes, we're fine. Woohoo! Okay. Remember domain restrictions, when we graph them after spring break, is where you'll see like a hole in the graph or an asymptote or a break. That's what that part of the graph is. Like you literally draw the graph and you stop and draw a hole and keep going. Okay. And to go back to yesterday's quiz, why do we do this? Why can it not be those numbers? Why can't the denominator be equal to 0? Nope. And make the whole thing undefined because you cannot divide by 0. It's not a thing. Okay, so that's why we do it. Y'all were really good with the how, not so as good on the why part yesterday. It was fun reading them though. Okay, here we go. Ready to come to this guy? No? This is a pretty good one. Pretty good one. Nothing too crazy going on here. All right. 1 over x minus 1 plus 1 over x plus 2 equals 3 over x squared plus x minus 2. I can factor that last piece, right? Oh, look at that. How nice. Right? So see how the fractions in the middle are just missing the other piece? Right? So here I need to bring in the x plus 2. Here we need to bring in the x minus 1. So I'm going to kind of do what I did last time. So the black is going to be what's there. The green is what we're bringing in. Did we bring anything to that last piece? No, we already had them all. Now what? Yeah, combine like terms and let's solve for x. So this just becomes x plus 2 plus x minus 1. That was nice to have those ones up there. X plus x is 2x. 2 minus 1 equals 3. Now what? Subtract the 1. We get x equals 1. Is that allowed? All right, so the math we did wasn't awful, but my answer, what is my domain restriction? I can't be negative 2 or 1, right? And literally the only answer we got was a 1. So this is an example of an extraneous solution, okay? X equals 1 is an extraneous solution. Extraneous solution. Okay, so look, notice I didn't say no solution, right? We solved x equals 1. It's something. It's not a solution I can use, but it's an extraneous solution. So that is the answer, okay? Fun fact, because the horizontal asymptote is at y equals 0, which is the x-axis, which is why we can't have an x. It'll all make sense when we bring all the graphing in. Ready? Are you ready to try one yet? Or you want me to keep going? You want to try this one? Because of those ones? Yeah? Okay, try it. We have 1 over x plus 3 plus 1 over x minus 5 equals 1 minus x over x plus 3. So they are all missing something. You got to bring something into each piece. Okay, you try it. When you're ready, it's up here. Does anybody know why I moved the x squared to the other side and didn't leave it where it was? Because it was negative, yes. Not gonna work. We don't want it to be negative. We want it to be a positive x squared. So I moved all of it to the other side. Factored, I got positive 3 and positive 1. Both are okay. I can put those into my denominators and never get a 0. Yeah. I'll step this way. Any questions? No? Ready for the next one? Are we still writing down this one? Yes? Okay, I'll give you a second. All right, lovelies, we got 2 more. What am I going to do first? I'm missing a denominator. But hold on. No, I'm missing one completely. Yes. Put it over 1. Okay? If there's 3 pieces to your equations, there are 3 different denominators you have to make be the same. Okay? So if 1 is missing, because it's a whole number, put that thing over 1 so you know what's going on. Okay? Because essentially that middle piece is missing all the denominators. Right? We got to bring them all in. Now, I heard someone say it. We are going to factor this first guy. Minus 5 minus 2. Okay, so that means my middle piece is missing both of those. Right? Let's do purple. This needs both of them. Minus 5 minus 2. And this last piece is missing the minus 2 part. Okay. See how that gets cramped? I feel like that gets messy. So we didn't touch my first numerator. It's still 3. Now we have plus 2 times x minus 5, x minus 2. And we are now equal to x minus 4 times x minus 2. So that's why I write this out. I feel like that's easier to follow than jumbling stuff within the equation. Okay. Ready? So 3 stays 3. Sweet. Here, we know this is x squared minus 7x plus 10, because that's what we used to get it, right? This side is what? X squared minus 6x plus 8. Am I going too fast? Okay. I'm going to distribute my 2 next. 2x squared minus 14x plus 20. I'm going to combine like terms, which is just the constants. So 2x squared minus 14x, this is 23, equals all of this. Woo. Okay, I got to get everything to one side, right? So I'm going to move the right side over to the left side. Do we know why I'm picking that? Yeah. If I move the 2x squared over, I get negative x squared. Don't want that, okay? So we're going to subtract the x squared minus 6x plus 8, move all those pieces over to the left-hand side. So we're going to subtract x squared from my other x squared. We're going to add 6x to the negative 14x. And we're going to subtract the 8 from the 23. So 2x squared minus x squared is now just x squared. Negative 14 plus 6 gives me negative, oh, what is that? Not 12. Yes, it is 8. Negative 8x. And then 23 minus 8 gives me, what is that? 15. Well, that's nice. I like this. That was a lot of work, but we like x squared minus 8x plus 15. Yeah. Negative 3, negative 5. So we get x equals positive 3, x equals positive 5, but Gotta make sure we can use them. So what are my domain restrictions? What is x not allowed to equal? Can't be 2 and 5. Remember, we go back to the beginning. We're looking here, right? 5 minus 5 would give me that 0. Can't happen. 2 minus 2 would make that 0. Can't happen. So I can't be 5 and I can't be 2. So what's my only good answer? That x equals 3. Okay? And I'm going to label this guy as extraneous. Okay. So mathematically it works, but plugging it back into our original problem with the denominators, we're going to end up dividing by a 0, which is undefined, which is not going to work. Okay? But that does tell me we're going to have some kind of break in my graph at the x equals 5 spot. All right? One more, right? Yeah? You want to do it? No? Still need me? That's why I'm here. Okay. I'll be here. If you want to do it by yourself, go ahead, work ahead of me. If you need me, here I am. Here we go. Here, I won't talk. I'm going to do this. Right? So that shows me that this side is missing the plus, right? And this side is missing the minus. My middle piece is not missing anything. So 1a plus 3 plus 2 didn't bring anything into the middle, right? So that's fine. Equals 5, but we brought in a minus 3 over there. Hey guys, you're either working ahead or you're working with me. But both of those have working in the description, right? So make sure you're doing that. Okay, thanks. This becomes just a plus 3. We still have plus 2. This side becomes 5a minus 15. This is nice, right? There's no a squared. There's no factoring. It's nice to take a breather. 3 plus 2, that gives me a plus 5. This side is still 5a minus 15. Doesn't really matter where you move what. I'm going to subtract a over here. And I'm going to add 15 to this side. So I have 20 now equals 4a. So I have a is equal to 5. Let's make sure that that's allowed to happen. Domain restrictions. Looking at my denominators, I could not be a positive or a negative 3, which is not 5, so 5 is good. Okay. I would say that bottom center problem is probably the most intricate problem you're going to get. But it's so good. Don't you feel like you accomplished something? Just me? Okay. All right. You got a worksheet? There are 8 problems on there. We will check our answers tomorrow when we walk in, and then we'll do our word problems.